And I'll just say this fairly quickly. There's the normal vector, and here's the k vector. Okay? K is perpendicular to the xy plane. Okay? There is some angle between these vectors that's actually very easy to calculate. Okay? A formula that's very similar to the formula you have for dot product. Take the magnitude of one vector times the magnitude of the other times the sign, and you get the magnitude of the cross product. So it's just like the expression for the magnitude of the dot product, except you use the sign. Okay? So, yep, camera was on. I had to keep losing track. Okay, so theta is this angle here. If this vector is parallel to k, what does that mean? That means that the surface is flat up here, right? Meaning that it has the same area as this region down in the xy plane. If it's tilted at all, well, it has greater area, right? Okay? And that greater area is in proportion to the reciprocal of the sine in a way that's real easy to understand if you just draw some right triangles. Okay? Now, I'm not going to make that analogy, but it turns out that and it's not hard to understand. If you think it through, you can probably figure it out yourself, given this picture, okay? The area at the top is the area in the plane over the sine of this angle, okay? Now another bit of notation, I use theta for the angle. Usually when we do it, we call the angle gamma. Now it's written small, I think it's too small to make much sense. But this is the angle, okay? And of course, that's a cosecant of gamma, right? If gamma is not, wait a minute. And I wrote that wrong, it's just cosine. No, it's a sine. I don't know. No, it's a cosine. Okay. When these are parallel, gamma is 0 and the areas are equal. The cosine is 1, right? If they're parallel. Because the angle is 0. Okay, then as the angle approaches 90 degrees, well, if you've got a big angle here, then you've got a lot of area on the top. If you truncate this prism with a steep plane, you get a lot of area up there. Truncate it with a flat plane, you just get the area of this. And it's all a multiple of this area, and that's the multiple. Okay? So that's important because then we use this to set up an integral for surface area.